Good morning, scientists. It is Thursday, April 23rd. And good morning. We're going to continue our discussions on the plate boundaries and what happens when different plates are moving because of the convection currents inside of the Earth that, remember, are this rising and cooling, rising and cooling, rising and cooling motion. And so we're going to talk about divergent plate boundaries today, and we're going to talk about um, transform boundaries here today. All right, so this is a quick review. All right, so in the Earth, and there's more detail on this in the video from yesterday. All right, so inside the Earth, you have the inner core, outer core, the mantle, um, and the asthenosphere, and then the lithosphere, and we have lots and lots of heat. In the mantle, we have molten um, rock, which is heating up and rising. And then as it gets away from its heat source, it's cooling and falling. And this convection current here causes this lithosphere, which is rigid and hard to kind of float and move around the Earth, which gives us most of geology on Earth. All right. Um, all right. So we went there. Remember, the Earth is got all these different plates, and these arrows show how they're moving and where they're moving. All right, and one of those places where they move is called a convergent plate boundary. And we talked about how when they come together, they make islands if it's in the ocean, and volcanoes which become islands, includes volcanoes on land if you have a crust there, and then lastly, it creates as mountains, such as the Ouachita Mountains, Rocky Mountains, Himalayan mountains, are all what are called folded mountains. But these are when these two come crashing up. So today we're going to talk about our convergent plate boundaries. I'm sorry, um, divergent plate boundaries. All right, so what's happening here, guys, is so if these plates can come together and smash together, what happens if they just start pulling away from each other, right? They just start pulling away from each other. And that's what happens. And when they do this, they're going to pull and it kind of expose the asthenosphere. So what you see here is these two plates are moving away from each other, and this is what happens when it happens in the ocean. Is if these plates are moving away from each other, you're going to leave a gap, and what's going to happen is this hot molten rock is going to rise to the surface and cause these little volcanoes, and you can see. But what's happening is as they come up, they're going to cool and make new crust, and this crust is continually moving away from each other. So these ridges show you what happened in the past. So these ridges here and here, they were right here before. But as these plates moved apart, these ridges, so it's almost like a little timeline to show us what was going on in the earth, how quickly was this spreading as well. And this is what happens, these are called mid-ocean ridges. This is what's happening in the Atlantic Ocean specifically, happening in certain places in the Pacific Ocean, and the Red Sea as well is where this is happening, and actually making the Red Sea larger um, as it pulls apart as well. And so the Red Sea is getting larger and larger as the African plate moves. And so what that looks like on our larger map is that's right here. Right, the Arabian plate is moving in this direction, the African plate is moving in this direction, and they're pulling apart. And the Red Sea right here is just starting to get larger. Doesn't that plate boundary is not moving a whole lot? I think I read it was a half an inch a year, but it's larger, getting larger, by half inch a year as the African plate and the Arabian plate are pulling away from each other. All right, the second thing that happens to divergent plate boundary is called a rift valley. And a rift valley is when this happens basically on land, is that these two continental crusts are pulling away from each other. And when they pull away from each other, you get cracks, you get magma coming up, you get some volcanic activity, but the land itself kind of sinks down because you don't have the crust around it to kind of support it. It creates these rift valleys right here. Eventually, they could fill with water and become oceans and seas over time. But the most famous example here is in Africa. There is a rift valley that goes for hundreds of miles near Ethiopia and Kenya. And so the divergent boundaries creates new crust, these ridges, and then these rift valleys also on continents as well. The country of Iceland is right on the middle of the Mid-Atlantic Ridge, and so that's where this happens enough. You can get enough volcanic activity, you could create land masses as well. All right, so that's what happens at divergent plate boundaries. So they don't converge, come together. They diverge, they go up away as well. And the last one is called the transform plate boundary. Um, and our transform plate boundary is just when these pieces of the crust, they don't come together, they don't pull apart, they just kind of slide past each other like cars driving on the interstate, right? And what happens here? Well, you get earthquakes. You're getting earthquakes. It also misaligns rock formations. So you notice that like this mountain and this mountain was kind of pulled apart. So these kind of faults help us to see how quickly the plates are moving, and you have earthquake activity as well. Some mountains can be formed. It's called fault block mountains. And a fault block mountain is when you have an earthquake, and instead of it sliding past each other, it rises up and down. And so the Grand Teton Mountains in Wyoming are examples of fault block mountains. There are also fault block mountains in Africa as well. And this is what happens at a transform plate boundary. Not all earthquakes happen at a transform plate boundary, um, but this is one thing that can happen. So the New Madrid earthquake, which really is probably one of the strongest earthquakes in more recorded history, happened in Missouri, southern Missouri, northeast Arkansas, and that was not at a plate boundary. That was at a fault. Well, a fault is just a crack in Earth's crust where there can be some little movements, but not like big plates being moved here and for. All right, so remember that our boundaries are our convergent plate boundaries. They come together and make islands, volcanic islands, makes volcanoes and makes mountains. And we have divergent plate boundaries, which create ocean ridges and new crust. Um, and then rift valleys, or transform plate boundaries, which really just misalign the Earth crust, but also causes some earthquakes. Now, one thing I do want to mention about convergent and divergent plate boundaries, how these work together. So if this plate in the ocean is going and diving down and getting melted here, that crust is going away. But on the other part of this would be probably a divergent plate boundary as it's pulling away, and this new crust is being made. So as the convergent plate boundary is melting crust on the other end, right now you've got new plates. So you have new crust being made over and over again when we talk about these pieces. All right, so I want you to look over these three plate boundaries, and I want you to go to Google Classroom assignment 4.38 and just give me a few sentences. Which plate boundary are you most interested in? As you're listening to this, which one do you thought was most interesting or thought more stuff happened at it? If you had to pick one plate boundary to do more research on or to study or to read up or do an experiment, which plate boundary do you think you would want to do? And go ahead and put that in Google Classroom 4.38. We're going to talk about this in our Zoom meeting this afternoon at 4. All right, so see you guys later.